Hi scholars, today we're going to take a look at some characteristics of graphs and sort of talk about different ways to identify and describe these characteristics. So here is a graph. This looks like a graph of, it could be a cubic function, could be another different kind of function. So let's take a look. Let's first off talk about domain and range. Okay, so I can describe the domain of this graph. Let's actually do it in a different color. Do it in blue. And so the domain of the graph is just saying what are the permissible, the possible x values, right? So when you see the word domain, you want to think what are the possible x values that are allowed on this graph. And we can see that this is a graph that it looks like it starts right here, right? So it starts when x equals -6. And the graph keeps going, keeps going, keeps going, and it ends right here. So it ends where x equals 3. So we could say here that the domain of this graph, right, of this function, is -6 to 3, right? And we have closed circles on each side, which means that it is inclusive of these points, right? So the point 3, -5, for example, is on the graph. If it was an open circle, it would mean that the graph contains all the points just up to that point, right, to the point -3 or 3, -5, but it does not include that point. Great, so that's the domain. So what about range? Okay, so range, the same way that domain was the x values, so range is really, we're just talking about the possible y values, okay? So let's take a look right here at the graph. So we start all the way up here, and we start at, it looks like +9, right? So that's sort of the maximum y value of this graph. And then what happens? Well, we go down, 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 down. We go up, and we go down again. And so here, you see how the y value at this point is -5. However, the graph itself goes even lower, right? So really, the minimum of this graph is actually right here at -6. So if we wanted to talk about what is the range, what are possible y values, right? We would say that, again, we always start from the smaller number to the larger number. So we'd say the range is from -6 all the way up to 9. Okay. So what else can we talk about? Well, we can talk about x-intercepts, right? So x-intercepts, just like in quadratics, it's the same idea. Let's use purple for x-intercepts. So the x-intercepts here are the points where the graph crosses the x-axis, of course, right? Here's our x-axis. And we can just sort of follow along and say, oh, there's one, and there's one. So it looks like they happen when x equals -5, 0, and +2. These are our x-intercepts. And we can also talk about y-intercepts. And this is where the graph, of course, crosses the y-axis, right? Here's our nice y-axis. And if it's a function, right, the graph of a function will only have one y-intercept. Because if it had multiple y-intercepts, it would not pass the vertical line test, right? It would say that for one input, for the input of x equals 0, there are multiple outputs, and we can't have that. So in this case, we look around, we say, where does the graph, in this case, the graph crosses the y-axis in exactly the same place as it crosses the x-axis, so the y-intercept is just going to be 0, or y equals 0. Okay, so we talked about domain, range, x-intercepts, y-intercepts. We can talk about one more characteristic of graphs, which is, are they increasing or decreasing? And that description is pretty self-explanatory. So let's look at increasing. So over what intervals is this function increasing? Well, again, we're going to start from our left, right, and move to our right and see what's happening. Okay, so first I start here and I go down. Does this look like increasing? No, this is decreasing. So I'm decreasing, I'm decreasing, I'm decreasing. Oh, I seem to be turning a corner. And then at this point, I turn a corner and I start increasing, right? The function values are increasing, right? And I keep going, and then it looks like I'm turning a corner here, and now I'm back to decreasing again. Okay, so I was increasing, it looks like, on an interval from here to here, right? You guys see that's the point where I have my arrows going up. So let's actually do it in red, even though we used that already. So I'm increasing from here to here. So we can say I'm increasing from the interval from -3 to 1, right? The x values, -3, and x values over to 1. And I'll be decreasing, let's see, I will be decreasing at all other points on the graph, right? Anywhere where the graph is actually getting smaller, right? The y values are getting smaller, are decreasing. And so that's going to be, if we go back to our graph, from here to here, all this is decreasing, and from here to here, we're decreasing. So that would be from -6 to -3. So I could say -6 to -3, and, right, I'm also decreasing from 1, it looks like from 1 to 3. Okay, from 1 to 3. And we'll notice that on this graph, I'm either increasing or decreasing. If I was neither increasing nor decreasing, right, there is a kind of a graph that does that. That would be a constant function, right? This graph, the graph of the line, for example, y = 4, right? This is the graph of y = 4. This graph is neither increasing nor decreasing. It is just a constant function. So that's an example of what that would look like. And so these are all pretty important characteristics that we want to consider when we're looking at the graph of a function and interpreting it. Let's take a look at a couple more examples. Example number 1. Sketch the graph of a linear function y = g of x with the following characteristics. G of 0 equals -4 and g of 3 equals 0, and then it says what is the slope of this line. Okay, so this right here, g of 0 equals -4, this is giving us an xy point. This is giving us a coordinate pair that is on the graph. When I input 0, my output is -4. In other words, the point, right, 0, comma, -4 is on my graph, right? So this is 0, -4, which is 0, -4. So here it is. So g of 0 equals -4 is this point right here. Let's keep going. Well, g of 3 equals 0. This is saying if I input 3, my output is 0. So we can just say that that means the point 3, 0 is on my graph. And I could find that point here. It's pretty easy, 3, 0, right? So actually, g of 0, this is telling us our y-intercept, right? And g of a equals 0, right? G of some number equals 0, this is telling us our x-intercept. It's another way of interpreting this information given in function notation. It's just as another way of giving us the y-intercept and the x-intercept. Well, now I have these 2 points. I know it's a linear function, so I'm okay to sort of sketch a line, you know, more or less, not the most straight line. There you go. And now I can, of course, answer the question, what is the slope of this line? Well, you know, slope is rise over run. So I want to say, how does the y value changes, right? So it looks like the y value is a -4. As I guess we can call it a +4 is fine. So the y value increases 4 as the x value increases by 3, and so the slope of this line should be 4/3, right? So slope is 4/3, and it makes sense that it is positive because this is a graph that is increasing, always increasing, right? It is increasing at a constant rate. So an increasing graph means the slope is going to be positive. Let's take a look at one more example. Example number 2. If f of -3 equals f of k, then what is the value of k? And so here's the graph of y = f of x right here. So how do we deal with a problem like this? Well, let's first off try to find the points that are given by this function notation, right? This right here, it's somewhere on the graph, so let's find it. So this is saying the function value when x is -3. Okay, so let's find it. So here I am. Let's go over to where x is -3. So here's where x is -3. So here we go. This is the function value. When x is -3, it looks like the y value, right, is -2. So f of -3 is another way of saying the number -2. Okay? There it is. This is the function value right here. And so the question is saying, well, that this function value is the same as the output of another input when you input k, right? So what could the value of k possibly be, right? What number could I input in order to get a function value of -2 on this graph? Well, right, we can cut to the chase here and say that here are all the possible function values of -2, right? And we already know that f of -3 gets me -2. So it appears that this thing would also give me f of -2, right? It's where sort of this line intersects the graph, our quadratic graph. And so in this case, this is the point 1, -2, which is another way of saying that f of 1, right, also equals -2, okay? So if I got f of 3 equals -2, f of 1 equals -2. So we can see actually that we sort of took a longer way around sort of talking through this, but in order to answer this question pretty quickly, pretty easily, I say what is the function value at -3, and then find me, right, we can draw this line and say find me where else this line intersects with the graph. It intersects right here. Okay, what's the x value here is 1. So the answer is k equals 1. Have a great week.